Good day, grade 11s. This is our first video for our study sessions. So this in front of you is an ATP grade 11. So if you can look at your ATP for term 1, you can see that for term 1 you have up to 3 topics that you must do. The first topic is vectors. The second topic is in Newton laws. Now Zian is highlighted bluish. Then the third topic, the electrostatics. So in those areas I'm going to, since I've already taught you vectors, so I'm going to do a revision question, maybe 2 or 3 with vectors, and then I will do another revision video for Newton laws, maybe 2, 3 or 4, and then I will do another video for electrostatics, again revision questions, the exam 2, 3 or 4 depending on the time. So yonke le information la phambi kwakho you do have, I did send you ku WhatsApp. This is your ATP annual teaching plan for term 1. And then when I'm done with the videos for term 1, I will send you videos for term 2 topics. So let's quickly now go straight to our first topic, which is vectors. I took a question from last year's paper, which is November 2022, Eastern Cape, grade 11. So this is how your exam questions will look like with topic here vectors. So we'll do this question, and then in the next video I'll do another vector question. So this question says a pulley system is used to keep a heavy object at rest as shown in the diagram below. So nansi diagram yako, you have a heavy object. So they use a pulley. There are 2 vectors here. There is a vector on the left, which is 1440 newtons. There is another vector on the right, which is 1284.95 newtons. And then there are angles between, as you can see, the heavy object, xa iphulwa ila vector is left, the angle between is 55 degrees. And then between the normal and the second vector, you have another angle which is 40 degrees. So let me label these angles. So okay, let's start first with the vectors. Now I'm going to label this one as vector A, then I'm going to label this one as vector B. So the heavy object also has a weight going down this way. I'm going to label that weight as vector C. So we have 3 vectors that are acting at a point, as you can see, but we don't know now the magnitude of the vector C, which is the vector for the weight. Okay, let's go to question number 1. Question 2.1 says define the term resultant vector. Define the term resultant vector. If you look at your notes, I did tell you last time that the resultant vector is the sum, or in fact they said is the vector sum, of 2 or more vectors added together. So according to the exam guideline, the key word there, vector sum, this term, the vector sum. Okay, let me change the color. So I'm going to highlight now this part, which is very important, the vector sum. That word is very important. That's That's when they will give you the 2 marks. If you mention that the resultant vector is the vector sum of 2 or more vectors added together. So that's according to your exam guideline. So let's go to question 2.2. Draw a vector diagram showing all forces acting on the object. Label the forces and indicate the angles on your diagram. So what they want here is a vector diagram. They said we must draw the vector diagram showing all forces acting on the object. Label the forces and indicate the angles. So we know that we have how many forces there? We have 1, force A or vector A. We have 2, force B or vector B. Then we have the third one, which is force C or vector C. All of them are acting at that point. So we need to draw now the vector diagram for this object. So last time I showed you how to draw this, but I'm going to do it again. So let me use my whiteboard. So what you need here, you're gonna need a ruler and a protractor to draw that vector diagram. A ruler and a protractor. The first step that you must do, you must always have a scale. You must always have a scale. So let's take a scale. So according to our scale, look, we have 1440 and 1284. Now we cannot draw these using your protractor and your ruler. So that's why you must always have a scale so that you can scale down these large values. Okay, I'm gonna show you now how to determine your scale. Okay, let's go back to our whiteboard. Let's say we have let's say 100 Newton must be equivalent to 1 centimeter, because we want to scale down our newtons. So if vector A is 1440 Newton, in terms of centimeters, what will be the value of vector A? So you just said 1000 on your calculator. You just say 1440 divide by 100. Then what do you get? 14,4. In centimeters, that value will be 14,4 centimeters. That means we can be able now to draw vector A, because we have reduced it now from these 1000 newtons to make it equivalent to 14.4 centimeters. Now let's look at vector B. Vector B is 1284,95 newtons. In centimeters, it will be equivalent to 1284,95 divide by 100. So it will be 12,8. So this one will be 12,8 centimeters. Now we don't know this one for C. Probably they will ask us to find the magnitude of vector C. So we will come to this one later on. So every time you are given the newtons in thousands, then your scale must be in hundreds. If they gave you your newtons in hundreds, your scale must be in tens, and so on and so on. So we have a protractor and a ruler. That's what you're going to need to draw your vector diagram. So let's quickly do the sketch first. So I'm going to sketch that graph here. This is the heavy object that we have, and then we have the normal, and then there is that angle from this point going this way, and then there is another one from this point going that way. So there is a pulley over there, and then the vector goes down this way. There's another pulley over there, and then the vector goes down that way. Then we know that vector C is also going down this way. So this is just a small sketch. You don't have to be accurate, just a sketch. I will draw the accurate vector diagram later on. So this is vector A, this is vector B, this is vector C. And then they said that here there's an angle of 55 degrees. If you can check again on the diagram, there's an angle there of 55 degrees. Then from the normal to that vector, there's another angle which is angle 40 degrees. From here to there, there's angle 40. And then here, there's angle 55. This is what they gave us. So I want you now to use your trigonometric angles, your trigonometric ratios to find the angles. So if you can see the normal, this is the normal. Let me highlight the normal. This is the normal. So let's say the normal is this line. So 55 is an angle that is in the perpendicular angle from the normal. From the normal to this point, there's 90 degrees. This is a 90-degree angle. But 55 is an angle within this perpendicular angle. So if 55 is an angle in the perpendicular angle, so what would be the other angle next to 55? So it's like we have 90 minus 55. I think it's going to be 35. Am I correct? Let's check on our calculator. I'm not good in maths. So 90 minus 55. 90 minus 55, yeah, it's 35. So we are correct there. The angle is 35 degrees. So we just wanted to know what is this angle with 40. Why do we need this angle now? Because if we add 55 and 35, we're gonna get 90 degrees, which is correct. But why do we need to find that angle of 35? So this is what I want you to see. If you have to draw the vector diagram, the vector diagram would need a closed triangle. That's what a vector diagram is. It means a closed triangle. So this vector, which is vector B, which is going at the angle of 40 degrees, I can put it here to be parallel. This is still vector B. I did not change any direction. So this line and that line are parallel, which means it's the same vector. I'm trying now to close my triangle to form like a parallelogram so that I can be able to detect and determine my triangle. Now look at this one. You have here vector A. If this vector is vector A, then we can still draw that vector on this side. This is still vector A. I did not change any direction. It's still vector A and it's still parallel and still 35 degrees. So I have now a closed parallelogram. But a parallelogram is formed by two triangles. So I have triangle 1 This is triangle 1. This is triangle 2. Both of these are my closed vector triangle. In the middle here you have your vector C, and your vector C is going down. So you can see your arrows are pointing at the tail of each vector. So arrows must not point at each other, they must point at the tail of each vector. So now it's a closed vector triangle. So we can say a vector diagram is a closed triangle. It is a closed triangle. So we need to choose now between these two triangles, but before we choose between these two triangles, we must get all the angles. We need to find this angle, we need to find that angle if you have to choose triangle A. But if you want to choose triangle 2, you have to find that angle and find that angle. So let's look at triangle 1. So for triangle 1, this angle, if you can see, 40 and this angle are alternate angles. In mathematics we said when you have two parallel lines and then there's a transverse line cutting these two lines, we say this angle and that angle are equal. So because of this and this are alternate angles. So if this is a B is a line, B is a line, then there's a transverse line cutting through, then angle 40 is alternate at that angle. So that is also 40. Similarly, if you look at angle of vector A and vector A, they are like this, vector A and vector A, and then there's a line, and there's a line between like this. So this 35 will be alternate at that angle. So this will be your alternate angle. So that means this will also be 35 degrees. So we have now two angles for each triangle. So if you want to choose triangle A, you need to go now and find that angle. Now there's a law in triangle that says that sum of the angles of the triangle are equals to 180. It's like if you have 180 minus 35 plus 40, what is that angle? So it's 180 minus 35 plus 40, I think is 75. So what is 180 minus 75? I think it's 105 degrees. Let's check. 180 minus 75. It's 105 degrees. So that means this angle is 105 degrees. I think it's the same here. Also, it's going to be 105 degrees. So now we have two triangles. You can choose any of these two triangles before you can draw the vector triangle. So for me, I will choose the one on the right. I'll choose triangle 2. I'll choose triangle 2. Let's create space here. So yeah, so I have my tools with me. Yeah, so I'm gonna use now these two tools, the protractor and my ruler. Let us not forget the magnitude of these two. We said vector A, the magnitude of vector A in centimeters. What was it again? The magnitude of vector A is 14.4 and 12.8. 14.4 and 12.8. So A is 14.4 centimeters, and B is 12.8 centimeters. So we're going to use now these values now in centimeters for A and B, because we know these two vectors. Now, how do you draw a vector triangle? How do you draw now a vector diagram? Yeah, it's a vector diagram. That's what we are going to draw now. So I'm going to choose now triangle 2. You can choose any of these. You can choose triangle 1 if you want, but I prefer triangle 2 in my case. So I'm going to take triangle 2. Okay, so where do I start? So this is not going to be easy for me because of I'm using the equipment in the computer. So I'm gonna take now my ruler. Okay, let's start with, let's take the ruler. Let's take the ruler. This is my long ruler, your 30 centimeter ruler, and then I'm going to make it straight towards the center. I'm going to make it straight, like vertically straight. Now, okay, it's vertical now. And then I'm going to draw now vector C. I don't know the magnitude of vector C, but I know it is just a vertical line. So I'm going to draw just a vertical line, a long vertical line. I don't know when it will end, but just a long vertical line. So I'm going to start here. I'm going to start here and just draw a long vertical line for vector C. Okay, I'm just testing here. Okay, my lines are working. So this is vector C from there straight down. Now, this is just my starting point. I don't know the magnitude of this line, but I just draw a long vector line. Then I take off my ruler to the side. Now I'm going to use a protractor. Now for a protractor, we need now to find the angle 35. We need now to find angle 35. So let me take the protractor. I think I need to flip it to the other side. Okay, I need to flip it that other way. Okay, let me rotate it to this other side. So I'm going to use my protractor now to find angle 35. So let me put the protractor like this. It's not easy. I'm trying my best. So the reference angle, which is 0, it must be straight on top of the line, which was vector C. So we're gonna count now. Let me make it bigger so you can see. Okay, I think now we can see. Let me put it close again. Let me put it on top of the line. It's on top of the line now. So what I want angle 35. So I want angle 35. So 10, 20, 30. 35 is between 30 and 40. 35 is somewhere here. So that is 35. Okay, I remove now my protractor. I'll remove my protractor. Let me just erase this line here. So I need now to draw vector A, because if I know the angle now from C to A is 35 degrees. Now I know the magnitude of this line. We said it's 14,4 centimeters. So I take my ruler again. I take my ruler. Now I need now to make my ruler to tilt towards that line, which is 35. Okay, I'm gonna do it like this. Now I need now to draw this line. Yeah. Okay, let me just put it close, and just need to put it close now. Okay, so my zero must be where I started. Just a little bit, but okay, will you just forgive me for that one? I can't do any otherwise, but you can see what I'm trying to do. Now let me just add a line now, and the line must be 14.4 centimeters. So 14.4 is somewhere here. 14.4 would be somewhere there. So I'm starting here, then I'm going down to 14.4. Here is 14.4. Yeah, it's somewhere there. So we did now. That was vector A. Oh, I think I made a mistake. The arrow is not supposed to go down. The arrow is supposed to look up. Okay, I think you can see there. Okay, let me not waste time. So this arrow is supposed to be pointing this way. So the arrow is supposed to be pointing this way. It's not supposed to be pointing that way. So you label your vector as A, which is equals to 1440 Newton. That is the magnitude of this vector. And the angle between C and A, you labeled it as 35. Remember, that's what they said in the question. They said draw vector diagram showing all forces acting on the object, and they said label the forces and indicate the angles. So that's what we are trying to do here. We have labeled, this is labeling, and then this is indicating the angle. So you'll get a mark for doing that. So we need now our last vector, which is this one, which is vector B. So vector B is somewhere here. So let's create space now for vector B. So we need vector B. So vector B is 12.8 centimeters at this point. 12.8 centimeters. We said the angle there is 105, so we need to find that angle now, which is 105. So let me take the protractor. I want to find now 105 degrees. So I take my protractor and then I tilt it the other way. Yeah, like that. 105. So my center must be on top of that end point. Then the line is supposed to be on top of each other. The zero line is supposed to be on top of my vector A. Yeah, it's on top of vector A. Now I want 105 degrees there, so I'm going to draw now 105. Let's count 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 105 is between 110 and 100. So 105 is here. Okay, 105 is here. It's between 100 and 110, that is 105. So we have indicated now. So let us now draw this vector now, and we know the magnitude is 12.8. The magnitude of B, there is it, is 12.8. Okay, I'm gonna use my ruler again. So take my ruler, then I need to turn it the other way, turn it the other way. We need now 12.8. so my ruler is supposed to be straight with the dot. Yeah, so I'm gonna start here from 0 to 12.8. Okay, I'm not now on the point that I wanted. Okay, so right, let me just draw this line. I'm gonna check where it ends. 12.8. so let's take a line. We start from where A ends, and then we draw a line which is 12.8. Okay, choose a line, choose this one. So we start here, we draw 12.8. 12.8 is somewhere there. Yeah, 12.8 is somewhere there. So let's remove the ruler. Let's check now. So we said now that vector C, it is just a long line that is going down. We don't know where it ends. So, but we are confident that this one is accurate. This is 105 degrees. And this line, we label it as vector B. It is 12.8, was it 1285,96? I think so, in newtons. You label it in newtons, don't label it in centimeters. And then the arrow for this one, B, is going this way according to your diagram. So it must not, am I doing it correct? No, I think I made a mistake there. Let me check. The arrow is supposed to go the other way. Oh yeah, the arrow for B is supposed to point out, supposed to point this side. Okay, I made a mistake. The arrow is supposed to point to the other side. So let me fix that one. Okay, so I take my eraser, then I erase there. That arrow is not supposed to look at, oh Lord. Okay, let me undo this one. Where is undo here? Okay, that is undo. Undo, yes. I want to erase this one. Undo. Yeah, that's excellent. So let me now write my arrow. So my arrow is supposed to point this way. That's correct now. Yeah, so what you just do now, you just now extend that line of vector C towards the end where it will intersect with the vector B. So you just extend that line. But since I'm using now a whiteboard in the computer, with you in your exercise book, you will see that this line will extend straight to the end of vector B, where vector B ends. So what I'm just gonna do, This was just a sketch to help you understand how to draw a vector line. So I'm just going to extend this line straight, but according to your book it's supposed to end directly there. The reason mine is not ending directly there, here is a problem. Let me show you the problem. The problem is here. My line was not on top of that dot, so that's why now this one is not straight towards the end. Anyway, we need to measure this angle. According to our diagram, this angle is supposed to be 40. You must measure it and then you will see it must be 40 exactly. So this is vector C. This is vector C. We don't know the magnitude of that vector. So let us now measure the magnitude of that vector and see what do we get. Don't just forgive me for not having a straight line. Yeah, next time I will try to make things very accurate. So let us now check this line. Let us now check this line. What is the magnitude now of this line? Yeah, I think I'm gonna try to measure this one. So I hope that you are also following in your exercise book as I'm doing this. Okay, my ruler is 20 centimeter. Unfortunately I don't have a 30 centimeter ruler, but as you can see it started from 0 going down. You can see here I have 20 centimeter at this point, but it's ending here. So I am assuming now C is supposed to be like 21. C is supposed to be like 21. Let's say 21 centimeters. Let's say approximately 21 centimeters. So if we put 21 centimeters in newtons, so remember we have a scale here. So let's put 21 centimeter. This is 21 centimeter. This is 21 centimeter. And then we want now to find what is 21 in newtons. So you set 21, you multiply again by 100. So you're gonna have 2100 newtons. 2100 newtons. Then we labeled that vector as 2100 newtons. Let's label the vector 2100 newtons. 100 newtons, and then let's remove this one. Yeah, so let's erase everything that we don't need now. Let's erase everything that we don't need. We don't need that one. We don't need that one. This one must also not show. Yeah, this is how you draw your vector diagram. Vector A, vector B, vector C. All arrows must not point at each other, but they must point at the tail of each other. So that's how you draw your vector diagram. So that was number, let's go back to our questions. That was number 2.2. It was 4 marks. So they will give you 4 marks for doing that. The last question now says calculate the weight of the object. Calculate the weight of the object. Now, if we knew the mass of that object, it was going to be easy to find the weight. For example, let's say for 2.3, if we knew the mass, we are going to use the formula W is equals to mg, and then we're going to put on the mass and then multiply it by g, which is 9,8. Then we would find our weight in newtons. But the problem, we don't know the mass, so we can't use this formula now. So we have to go back to the diagram again. Let's go back to the diagram. So to find now the weight of that object, as you can see, this 2100 Newton is the weight itself. But in question 2.2, they did not say we must determine the magnitude of vector C. They just said, let us just draw the vector triangle. So let us assume that we did not know what was the magnitude of vector C. So in this case, this is how you are going to find out this one. Let me use another color. So there is a sine rule, which is, there's a formula of a sine rule which says, the formula of a sine rule, there's a formula that says A over sine angle A is equals to B over sine angle B. So there is this formula that you can use to find now the side C. So this A is like a side, this B is like a side. So it says side A over sine of that angle is equal to side B over sine B. So I'm going to use this formula for this calculation. So this is side B. So as you can see here, this is side C, and it is facing that way towards this angle, which is 105. We have another side here, then this side is facing at this angle, which is angle 40. We have another side here, which is side B. It's facing at this angle, which is 35. So all of these are sides. So what you do in this formula, you take the side that you want. We want this side, side C. So I'm going to say side C all over. It's facing towards this angle, which is 105. So I'm going to say sine 105 degrees is equals to, and then there's another side. You can either choose, because if we know the side, we know the angle. We know side B, we know the angle. So you can choose any of these. If you set side A over, what is the side A facing? Side A is facing towards 40 degrees. So I'm going to say here sine 40 degrees. Then I'm going to substitute side C, which is the side that I want, which is C all over sine 105. So I'm going to say sine 105 degrees is equals to side A. Side A is this value, which is 1440 over sine 40 degrees. Now I have my unknown, which is C. These are two fractions. Then what do? We cross multiply. So C times sine 40 is going to be C sine 40 degrees equals to 1440 multiplied by sine 105 degrees. Now I can multiply these two to get this value, divide by this side. So we're going to divide by what we don't want. We don't want this one, sine 40. What we do on the left, we do it also on the right, sine 40 degrees. Then we take the calculator. You take your calculator. You remember these two will cancel. On the left, this and that will cancel. We'll be left with C, which is equals to, so we have 1440 multiplied by sine 105. Let's punch that on the calculator. Make sure your calculator is in degrees. There you must see a D there. There must be degrees there. So our calculator is in degrees. So we have 1440 multiplied by sine 105. divide everything. Okay, let me put it in a fraction form. I like it this way. Fraction form is 1440 sine 105, and then in my denominator I have sine 40 bracket answer. So the answer is 2163,91. 2163,91. Yeah, it's 91, and it's in newtons. Now if you compare this value and this value, that means we're accurate. Remember here our line was not straight towards, so if we could have drawn this one straight, we could have find the same value, which is 2163,91. so this is the accurate weight of vector C. Also with our measurements, we were approximately close to 2163,91. So I think that is the end of the question. The question was 9 marks. Okay, grade 11s, now I will see you in the next video.